Okay, question 4. Every morning, Samuth has one glass of fruit juice with his breakfast. He chooses at random orange juice or pineapple juice or mango juice. The probability that he chooses orange juice is 0.6. The probability that he chooses pineapple juice is 0.3. Work out the probability that he chooses mango juice. Now, the trick here is to realise that he's got 3 choices and that's it, hasn't he? Orange, pineapple and mango. That means that the probability of all those 3 happening must add up to 1. And once you've realised that, then it's fairly straightforward. We just do 1 minus 0.6 minus 0.3, okay, and that will leave us with 0.1. There are 30 days in April. Work out an estimate for the number of days in April on which Samuth chooses orange juice. Okay, now the probability for him choosing orange juice, we'll call that PO, equals 0.6. Yeah. Now that is the same as 6/10, isn't it? Or you could think of it as 6 out of 10. So in other words, if he was choosing a drink 10 times, then you would expect him to choose orange juice 6 out of 10. Yes. So if he's choosing orange juice, if he's choosing a drink 10 times, then you would expect him to get 6 orange juices, basically. Now what we need to do is think, well, what if it was 30 days? So in other words, we want it to be out of 30. Yeah. We want to know. This. So to get from here to here, f times by 3. So I must have to do the same to the top as well, mustn't I? And that means that this will be 18. Okay. Now, so that means that if he's doing this 30 times, you would expect him to get 18 orange juices. Done. Now there is another question on this sheet, which is question 5. 5/6 minus 3/4 equals a 12. Now I quite like these show that questions because you know what you're working towards, and there's no excuse for getting them wrong either, is there? So let's have a look at this. 5/6 minus 3/4, and you know, when you're subtracting or adding fractions, of course, you've got to make the bottom numbers the same. Now, so that means you've got to find a number that both 6 and 4 will go into, and preferably the lowest one as well. Okay, now 6 and 4 both go into 24, so you could put 24 on the bottom, but it would be better if you put 12, because then you'll have less work to do later on. So I'm going to go for 12, which is what we call the lowest common denominator. And then you have to think to yourself, okay, what have I multiplied 6 by to get 12? Well, I've multiplied by 2, which means that I'll want to do the same to the top. So that's 10. And what have I done to the 4 to get 12? Well, I must have multiplied by 3. So I must do the same to the top, which means I'll get 9. So I end up with 10 twelfths take away 9 twelfths, which is just 1 12th. Whatever you do, do not subtract the denominators. We're talking about twelfths here. 10 twelfths take away 9 twelfths leaves 1 12th. Okay. So the answer is 1 12th. So we've shown it, we've proved it. The total for that was 2 marks. Okay, 2 marks. If you don't show you're working, you may not get any. Right, question 6 is a transformation question, and it's asking you to describe which type of transformation, maps or makes P go to Q. Okay. Now, you've got 4 options. You've got reflection. You have got enlargement. We've got translation, and we've got rotation. And if you're not sure which one which one applies to a question, whether it's reflection, enlargement, translation, or rotation, it's usually quite easily to eliminate the ones it isn't. Okay, so we'll start with reflection. I can't find a mirror line anywhere there. I can turn my head this way, that way, but I cannot see a mirror line, which means that it isn't going to be reflection. Okay. Enlargement. Have we enlarged anything here? No, it's exactly the same size. Okay. It should be bigger or smaller if we've enlarged it. Translation. Well, translation just means to move something, doesn't it? If we translate something, we don't reflect it, we don't rotate it, we don't enlarge it, we just move it. It stays in the same orientation as it was. Now, as you can see here, there's a change in orientation, which means that something's happened other than just moving it. So it cannot be just a translation. So we're left with rotation. And then you should say to yourself, okay, well that means I've got 4 things that I need to say. The first is that it's a rotation, which sounds ridiculously obvious, but people, because they know it's a rotation, they forget about putting that one down. Yeah, so you would lose a mark if you didn't put rotation. The second one is the direction of the rotation. The next one is the angle it goes through, and also the center of rotation. So you need to specify all 4 of those things. Now, so let's look at the direction. Well, I'm looking at P here, and I can see straight away, if I rotate that by 90 degrees this way, okay, you're going to end up with something that looks like that. So I'm not thinking about where it's rotating about at the moment. I'm just looking at the shape itself. And so obviously this is the same as this, isn't it? So you can see that the shape has been rotated by 90 degrees, and it's in the clockwise direction. Clockwise. So we've got 90 degrees there, okay, and this one here is that it's clockwise. Okay, so now we've just got the center of rotation to think about. Okay, just clear the decks there. And so we know it's a rotation, but where is the center of rotation? Now this is where you put your hand up in an exam and you say to the invigilator, please sir or miss, please can I have some tracing paper? And they will give you some, because they like that. And you put the tracing paper on the paper, you trace over the shape, the original shape, which in this case is P, okay, and then you put your pen, the point of your pencil or your pen, on the paper where you think the center of rotation is. And it's just guesswork. I mean, maybe you think it's here. It's always on the grid somewhere. It's not halfway. I mean, it's always on the grid. It's on a point of intersection on the grid. So you look at that. You put your pencil point there, and you rotate the paper, and see if your outline here that you've drawn here fits on top of this shape here. And if it does, you've solved it. If it doesn't, you'll have to try again, and it is just trial and error. And you would find eventually for this one, I'm looking, and I can see that it's actually going to be there. Okay, and the way I did that was I can see that, look, if I rotate this L shape here, yes, by 90 degrees clockwise, it will end up here. So that's the way I did it. I just use what I know about rotate. I use L shapes too. So you can do it without tracing paper, but always check it with tracing paper, even if you do something like what I've done there. So this is your center of rotation. So the answer to the question would be, it's a rotation. 90 degrees clockwise, about 0, 0. Done. Okay. Now the next thing it asks us to do is to reflect the triangle Q, which is this one, in the line y equals x. So that's our mirror line. Now how do we draw the line y equals x? Well, that's quite straightforward, because what it's telling us is that whatever value x has, y is the same. So if x is 1 here, y must be 1. So that means that we get a point here. When x is 2, y is 2. And this is you should know this off by heart, this graph. You should realise it does that. Okay? And if I just draw a line, then you can see it goes straight through there like that. And then it shouldn't take too much to see that in fact the shape, then in that case the reflection will be there. If not, if you can't see that, put your tracing paper on here again, okay, and use your tracing paper to work out where this is here. Very straightforward. And I've got to label that R. Don't forget to do what it tells us to do. Okay, and we'll continue with question 7 on the next video.